Hi everyone, welcome to the video lecture series of compiler design. In this video, we will be learning what is compiler design, its definition, key phases of compiler, importance of compiler design, and applications of compiler design. So let's understand what is compiler. Make sure to watch the video completely so you can have better understanding of this topic. So a compiler is a special program that translates code written in high-level programming language like C, C++, or Java into machine code that a computer processors can execute. This translation process is crucial because computers only understand low-level machine language, not high-level programming languages. So compiler is a special program that translates codes written in high level programming language like C, C++ or Java. We know that we cannot communicate computers or device computers with or like system software like how we communicate with each other in English or another languages. We need a programming language like C or C++ or Java or a language that a machine understands, and this machine language itself is not understandable like in the first go. So machine understands the high level programming language like C or C++, which we communicate through that. So machine understanding that language is known as compiler design. So I hope you got that. High level programming language is C or C++. Low programming language is what the compiler understands, or the processor or computer processors can understand or execute that. So there exist key phases or important phases of a compiler, that is lexical analysis, step 1, and syntax analysis, semantic analysis, intermediate code generation, code optimization, code generation, and code linking and assembly. These all are like separate topics in itself. In this video, we will only understand the basics of these definitions. This is not like a complete answer that you would write and get marks. This is like an introduction part. If you get a question of writing what is compiler and its phases, you can write this answer. If it is asked to write about single part of syntax analysis completely, you cannot write that. I will make a complete video of these topics soon. So in this video, we will understand simply basics of these phases of compiler. Let's dive. What is lexical analysis? This is the first phase where the source code is scanned and converted into tokens. Tokens are the smallest units of meaning in our program, such as keywords, operators, identifiers, and literals. So lexical analysis is like a first step in which the level programming language, that is C or C++ or Java, is converted into tokens or smallest units such as keywords, operators, identifiers, or literals, and it is divided into like the high level language is divided tokens like in keywords. The first phase where it is converted into tokens like divided into keywords, operators, or identifiers. In the second phase, it's also known as parsing. In this phase, the compiler checks the tokens against the grammatical rules of the programming language. It produces a parse tree which represents the syntactic structure of the source code. We'll understand parse tree in coming videos. Understand syntax analysis. It is like syntax is a set of rules that of a programming language that you must make a mistake in the syntax for the code, high level code, for it to process in the low level language. So in this, it produces a parse tree to represent syntactic structure of the source code. In syntax analysis, we understand the syntax or the rules of the programming language and check if it is not making any mistakes, or if the high level language is not making syntax mistakes, so we can proceed for the next step. So syntax analysis is that. And the third phase is semantic analysis. In this phase, the code is understand logically and semantically. It checks for the typing errors, undeclared variables, and semantic inconsistencies. So in semantic, the logic and semantic is checked. In the next phase, that is intermediate code generation. Here the compiler translates the source code into an intermediate code that is easier to optimize. This intermediate code is often machine independent. Intermediate code generation is a source code that is translated into an intermediate code that is easier to optimize. We'll understand this in deeply. It is intermediate code that is easy to optimize for easy execution and to manage the storage as well. And in the next phase, that is code optimization. In this phase, that previous intermediate code is optimized to improve performance and reduce resource storage. This involves removing redundant code and optimizing loops. In this phase, we optimize the intermediate code that was generated previously. Intermediate code is a code that is generated from high-level language for a machine to understand in low-level language. This involves removing redundant code and optimizing loops. And in code generation, the optimized intermediate code is then translated into the machine code for specific processor. This machine code is what the computer CPU can execute directly. This machine code or the code is translated into machine code for specific processor. This means like the code that is generated after code optimization, that code is translated into machine code for specific processors or the hardware to understand that. This machine code is what computer's CPU can understand and execute directly. After the process of intermediate code generation and optimizing that intermediate code, and this code is now ready for the processors or the CPU to execute directly. And in the last phase, that is code linking and assembly, finally the compiler links the machine code with other code libraries and converts it into an executable file. So in the last phase, the compiler links the machine code which is generated previously with other code libraries. So let's understand now the importance of compiler design. Efficiency. A well-designed compiler produces efficient machine code that runs faster and uses less memory. And error detection. Compilers can catch syntax and semantic errors in the development process, making debugging easier. Portability. By translating high-level code into machine-independent intermediate code, compilers can help programs portable across different hardware platforms. Optimization. Compilers can apply various optimization techniques to improve the performance of the generated code. These are the importance of compiler design, in which in efficiency, the compiler produces efficient machine code that runs faster and uses less memory. And in error detection, compiler catches the syntax error and semantic errors early in the development process, making debugging easier. Debugging is the process of finding the errors. Compilers help catch syntax and semantic errors earlier than in the development process, so it makes debugging easier. For the portability, the high-level code that was generated can be used for other hardware platforms as well. It is not like we have compiled a high-level code into low-level code that can only be used for that same device or the hardware. That high-level code converted into a low-level code or machine code that can be used for other devices that are compatible with that of the same device. So yeah, it provides portability of that machine code generated. And for optimization, compilers can apply various optimization techniques to improve the performance of the generated code. As I mentioned before, optimization is optimizing the machine code that was generated to increase the efficiency and use of the less memory to perform, like it increases the performance of the generated code. So let's understand the applications of compiler design. So I hope the video is insightful and helpful. Please don't stress like this is sounding a bit of complex. I will explain in depth with the concepts of, as I mentioned, like these 7 phases. These are very important. These phases will be understood in a separate video. A single video introduction cannot be sufficient to understand that. So in this video I tried my best to make it simple to understand the basics of the phases, so you can remember in the exams. This video as an introduction of this compiler design helpful. Please make sure to like, share and subscribe to the YouTube channel so you will not miss the videos which I will be posting on education. So yeah, let's dive into the applications of compiler design. It is helped. It is important in software development that helps software developers, allowing them to write and deploy applications. Compilers are essential tools that are used by software developers. They use them to write and deploy applications. In embedded systems, compilers translate code for embedded systems, enabling devices like smartphones, IoT gadgets, and automotive systems to function correctly. Compilers translate the high-level code that can be understood for the machine, like embedded systems, for example, smartphones, IoT, automotive systems, to function correctly. In depth, you can understand the analogy. Like we are communicating with the hardware. So high-level language, which is like programming languages that are converted for the low-level languages that helps communicating with smartphones, IoT gadgets, automotive, and function them correctly. And it is used in high performance computing. Optimized compilers are crucial for applications requiring significant computational power such as scientific simulations and data analysis. So, compiler design is a foundational aspect of computer science that enables the translation of human readable code into machine executable instructions, ensuring efficiency, error detection, and portability in software development. So this was the video in which we got a basic understanding of what is compiler design, its phases and importance and applications of compiler design. So let's dive now into the quiz. If you have understood the concept which I mentioned in the video, this quiz will help you make make it more easy to remember the answers. So yeah, you can try answering these questions and mention in the comments. So these are the questions. I think it's 13 questions for this video. You can pause and check for the answers. Yeah, you can pause it. So this was it for the video, guys. I hope it was helpful. Please make sure to subscribe, and I'll meet you soon in the next video. Until then, thanks so much. Have a great day.